Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, what happens when we specify the final non-access modifier with variables, methods, and classes in Java. Let me answer this question with theoretical explanation followed by the practical demonstration. So there is a modifier, guys. Okay, there is something known as modifiers in Java. Let me explain something about the modifiers a bit before I explain the actual answer for this question. Let me give a small idea about the modifiers in Java. Modifiers in Java can be at a high level categorized into access modifiers, and the other one is the non-access modifiers, guys. Okay, non-access modifiers. Under the non-access modifiers category, we have something like static is one of the non-access modifier. Other one is the final non-access modifier, and the other one is the abstract non-access modifier. And coming to the this final non-access modifier, which comes under the modifiers in Java, when specified before the variables, methods, and classes, will modify the non-access behavior of that particular variables, methods, and classes. So how the final non-access modifier is going to work? Let me explain. Okay, when you specify before a variable, what happens in Java? Okay, when you specify the final non-access modifier before a variable, how it is going to change the behavior of the how it is going to change the behavior of this particular variable, original non-access behavior of this particular variable, how it is going to change, you will understand. Similarly, when you specify the final non-access modifier before a method, okay, how it is going to change the okay actual behavior to some other behavior of this particular method, and similarly how the behavior of the class will get modified on specifying the final non-access modifier before the classes. Okay, all these three items I'm going to demonstrate, guys. Okay, so coming to the first one, guys. First one is about the first one is about the you know about the variables, guys. First one is about the variables. Okay, first one is about the variables, guys. Coming to the variables, guys. Okay, when you specify the final non-access modifier before a variable, the initialized value for this particular variable cannot be updated. Okay, you cannot update the initialized value. The first value that you are going to assign to the variable, right? That particular first value of the variable you cannot update, guys. When you specify the variables with final non-access modifier, you cannot update the value that is initialized to it in the first time. Okay, it cannot have second updated value or third updated value. The first initialized value is a final value. It cannot be updatable. And coming to the methods, what happens when you specify the final non-access modifier before the methods? Those methods cannot be overridden by the child classes. Okay, in the child classes of this particular class where this particular method is created and specified with final non-access modifier, right? In its child class, okay, that particular class where this method is there, of that class, child class, there we cannot create the overridden method for this parent class method. Okay, the final non-access modified specified methods in the parent class cannot be overridden in the child classes, in its child classes. And third one, what happens if you specify the final non-access modifier before the classes? If you specify the final non-access modifier before the classes, right, then what will happen, guys? The classes cannot be inherited by other classes. That means parent class cannot have the child classes. You cannot create child classes, okay, or any of the class in Java cannot become a child of this particular class to which final non-access modifier is specified. This is how the original behavior of the variables, methods, and classes will get changed when you specify the final non-access modifier before any of these things. Okay, as I mentioned here. So let me practically demonstrate and make this particular answer even more easy and better to understand for you, so that you can answer this question in a better way in the interviews. Okay, fine. So here, instead of making this particular question very big, right, what happens when we specify the final, why to write non-access? Okay, specify final modifier with before, okay, before variables, methods, and classes in Java. This is good, guys. Why to make it very big? Okay, this is very simplest form of asking the question anyhow. Yeah, fine. Anyhow, I'll go to the Eclipse IDE and take you to the location. Just give me a second. Let me take to the location where I can write the code. As you can see, the Eclipse IDE has launched, and here under one of the package known as modifier stack, which I have created as part of the previous answers of this series. Okay, so let me create a new class, new package only. First of all, under this, I'll create a sub package just for separation purpose and just name it as 11 is also there, 12. 12 name, click on finish, and yeah, it got created, guys. Now let me create a new class. I'll just name this class as you know final demo, final non-access modifier demo. I'm going to give here, or I'll give some sample name like class A or something. Class A, let's say. Why to give kind of name? Class A, I'll give. Click on finish, guys. When I click on finish, and inside this, I'm going to create a variable int a is equal to 5. Now I'll create a method, guys. Public. Okay, int a I'll say for now. Int a I'll say. Now I'll write public void sample method I'm creating. Inside this sample method, I'm going to write a is equal to 10. A is equal to 10. I'm going to initialize the variable value here. And later, if I say a is equal to 20, that's also fine. A is equal to 30, that's also fine. I can keep updating the value of this particular variable. It is a variable, guys. It's a variable. Now, what if I provide final non-access modifier before this particular variable? I'm already getting an error message that was not there earlier, asking me to initialize the variable first in the same line where it got declared. That means I cannot initialize the variable here. Rather, I have to initialize the value of this particular variable in the same line where it got declared. Okay, the final int a in the same line, I have to assign the value. I'll assign it as 5, guys. The moment I assign it as 5, the error is gone here and it has shifted to this place. Why the error is coming here, guys? The final field class a dot a cannot be assigned. You cannot update the value of this particular variable a. Once you initialize the value to this particular final modifier specified variable, right? You cannot update the value of this particular variable. 5 cannot be updated with 10 or latest value 20, 30. That is not possible. This is not possible, guys. That's the reason we got the error. In the same line where you have declared, you have to initialize, and also the initialized value cannot be updated further wherever in the program. Okay. So this is what the final will do to a variable when you specify it before the variable in Java. Okay. You have to initialize the variable value in the same line and you cannot update the variable value. Second thing about the final is if you specify this particular final modifier before a method, okay, public final like this, public final void sample system.out.println, inside sample method of class A. Inside sample method of class A, if I write like this, okay, if I create the public final void system.out.println inside sample method of class A, if I write like this, right, what will happen in this case? In this case, what will happen, guys? This method cannot be overridden by the child classes of the class A. What if I create one more class here? Class B, and here I'll write down extends class A, class B extends class A. If I write like this, something like this, guys, what will happen? This particular variable, okay, this particular method cannot be overridden. If you try to copy paste the same method here, you see you will get an error. As it is, I copy pasted. I'll just write down class B here inside sample method of class B. I cannot override the method that is there in the parent class in the child class. If that particular method in the parent class is specified with final modifier, the overriding is not possible. Cannot override the final method from the class A. Along with that, you can also provide the annotation, guys, override. Here also you'll get the same error, cannot override, you will get, okay, the final method of the class A. It is optional anyhow. So this particular method that is there in the parent class specified with the final modifier cannot be, overridden in the child classes. So this cannot be done. Okay, that's how the method behavior will get modified and specify the final modifier before a method in Java. And coming to the specification of the final modifier before a class, what will happen? You see, earlier this error was not coming. The class B was properly extending the class A. That means class B has properly become a child class of the class A earlier when final modifier was not there. Again, I will remove this and see that the class B can now become the child class of the class A. When final modifier is not specified in the class definition, any other class can become the child class of the class A, or class A can become the parent of any other class in Java. But the moment you provide final modifier before a class in Java, no class in Java can become the child class of the class A, because class A cannot become parent of any other classes in Java. That's what happens. That's how the behavior of the class will get modified by specifying the final non-access modifier before the classes in Java. Okay, so hope guys you understood what happens. Okay, I'll just comment this part so that error will be there otherwise. Okay, final modifier specified variable values cannot be updatable. Okay, and final non-access modifier specified methods cannot be overridden in the child classes. Final modifier specified classes cannot be inherited by any other child classes, or it cannot contain any child classes, or any class cannot become the child of this particular final modifier specified class. Okay, it cannot become the parent of any class in Java, guys. Okay, so hope guys, with the theoretical explanation followed by the practical demonstration, I've answered this question for you. So that's all for this session. Thank you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, what is the difference between abstract classes and interfaces in Java? Let me answer this question first with theoretical explanation followed by practical demonstration. So to make this comparison of these abstract classes and interfaces easy, okay, here in the Paint software, I'm going to write down abstract classes on one side and interfaces on other side so that we can remember. Abstract classes. Abstract classes this side. I'm going to write about the abstract classes this side. And on the other side, I'm going to write about the interfaces. I'm going to write about the interfaces on the other side. Okay. Interfaces on the other side. Okay, abstract classes on one side and interfaces on the other side. I'm going to compare these abstract classes and interfaces now. I'm going to compare the abstract classes and interfaces now. So fine. So let's get started with the comparison or finding out the differences between the abstract classes and interfaces. Coming to the abstract classes, abstract classes are all about the partial abstraction, guys. Okay, abstract classes means partial abstraction. Generally speaking, guys, abstract classes are all about, okay, the requirement why we use abstract classes in real time in the programs is for partial abstraction. Okay, if you want to achieve full abstraction, then you have to go with the interfaces, guys. Okay, so how come the abstract classes implement partial abstraction? How come the abstract classes support partial abstraction? Because they contain two types of methods. Abstract classes will contain two types of methods. One are abstract methods, zero implementation, which doesn't have the method body. Zero implementation. You cannot actually write any code inside these methods. Only definition will be there for that particular method. They are abstract methods. And other type of methods are non-abstract methods. You can also call them as concrete methods, and concrete methods. And here they contain implementation. Okay, abstract classes can contain two types of methods. One is abstract methods and non-abstract methods. Whereas interfaces, guys, are full abstraction. Interfaces are of full abstraction. Okay, they are aiming for full abstraction. Okay, and they generally contain by default, when we create methods inside the interfaces, normal methods inside the interfaces, when you create, they are by default abstract type. That means no implementation. Okay, that means they will not contain any implementation. Okay, that's why using the interfaces we can achieve full abstraction, because by default when you create the normal methods inside the interface, right? Okay, they will not contain any implementation. They are abstract methods by default. The normal methods created inside the interfaces cannot contain the method body, and they are by default abstract type base. Okay, then there are some things, okay, you need to understand. Abstract classes are all about the partial abstraction. They contain both abstract methods and non-abstract methods. Just now I explained here. They contain both the abstract methods, which contain zero implementation, non-abstract methods, which doesn't contain implementation. And coming to the interfaces, okay, they are all about the full abstraction. By default, when we create methods inside the interface, they are by default abstract type. They doesn't contain the, okay, by default when we create methods inside the interface, they are by default abstract type. Okay, it aims for the full abstraction, guys. None of the methods in the interface are to be implemented. The general purpose of the interface is that when you create the methods inside the interfaces, okay, they should not contain the method body. Okay, they should not contain the method body. Fine. So Yeah, variables inside the abstract classes are normal variables. Okay, the variables that can be created inside the abstract classes are normal variables. There are some exceptions here, guys. I'll tell you. In interfaces, I was saying that all the methods inside the interfaces are by default abstract type, but in the latest versions of Java, if you see the latest versions of Java like Java 8, Java 9, some different type of methods got introduced, okay, where they can contain implementation, guys, but it's not that they're going to break the concept of full abstraction. We try our level best. Whenever we create an interface, we create an interface with an intention of full abstraction only still, even though latest versions of Java, like Java 8 onwards, Java 8, Java 9 onwards, we got some different type of methods in the interface which can still contain the method body. Okay. Still, interfaces support full abstraction, guys. The main purpose of the interface is for full abstraction. Okay. Main purpose of the interfaces is full abstraction, guys, where by default the methods when you create inside the interfaces are by default abstract type. You don't have to even mention abstract keyword, etc. They cannot contain the method body, but starting from the Java 8 onwards, some methods can be implemented, guys. Methods created in the interface are by default abstract type, but starting from Java 8 onwards, interfaces can have default methods. There are some default and static method types which can contain the method body still, but their purpose is different. Their purpose is not to break the full abstraction here. Their purpose is some other thing, guys. Okay, from Java 9 onwards, I don't want to explain why default methods and static methods got introduced in interfaces. Okay, but they can have the method body. I can mention for now. Okay, if I keep on teaching about why they contain the method body and all that, the session will become very big and we'll get deviated from the question. And from Java 9, they have introduced the private methods also. That private methods also can contain the implementation. Okay, so Java 8 has two methods introduced: default methods and static methods, which can contain the implementation in the interfaces. Similar to the abstract classes, they can contain both abstract and non-abstract methods, right? Where abstract methods doesn't contain the implementation and non-abstract methods contain the implementation. Interface also can contain the abstract methods and non-abstract methods indirectly. Okay, by default, the purpose is full abstraction where all the methods by default are abstract type, but by creating the default keyword, by specifying the default keyword before the methods explicitly, or by specifying the static keyword before the methods explicitly, or by specifying the private modifier before the methods explicitly in the interface, they can still contain the method body even in interface also. But the aim is for full abstraction, guys. Aim of the abstract classes is partial abstraction, whereas the aim of the interface is full abstraction. Due to some XYZ reasons, there may be some situations that will be coming in your project where some methods should have the implementation, guys. That's the reason. Okay, this kind of methods got introduced, but not to avoid the full abstraction. That's not the reason, guys. Okay, fine. Anyhow, the common point that you can see here between the abstract classes and interfaces is anyhow. Before going that, I'll make a documentation here. Except default, static, and private methods. Okay, can have the method body except default. And the third point is a common point, guys. I'll write in between here, guys. It's not a difference, but whether you take abstract classes or interfaces, we cannot instantiate them. We cannot create objects. We cannot create objects for abstract classes and interfaces both. If you try to create an object for abstract classes, you'll get a compiler error saying cannot instantiate. Similarly, when you try to create an object for the interfaces, still you will get cannot instantiate kind of error. You will get compiler error. You will get. So for abstract classes and interfaces, we cannot. Okay, we cannot create the object. Okay. The next thing here is cannot create objects. Variables created in the okay. Next thing is yeah. I'll tell you the next things, guys. Okay. We cannot create the objects. Then what is the solution here, guys? Okay, the solution here is this one. The solution here is this part. Here also the solution is there. Even though you cannot create objects here, okay, for abstract classes, even though you cannot create objects, you can create child classes which can implement this abstract methods of the abstract methods in the abstract classes can be inherited by the child classes and can be implemented. For the child classes, you can create the objects. Directly, you cannot create objects for the abstract classes, guys, but okay, by using the keyword like extends keyword, you can create child classes for these abstract classes, and whatever the abstract methods that are not implemented in the abstract classes can be inherited by their child classes, okay, in the form of is a relationship, Okay, in the form of is a relationship, the child classes will inherit the abstract unimplemented methods from the abstract classes and implement them. So even though you cannot create objects for the abstract classes directly, but for the child classes which are implementing the abstract methods of the abstract classes, we can create objects, guys. Okay, and this kind of relationship where a class inherits from an abstract class, okay, it establishes a is a relationship with the abstract class, guys. Okay, when any class, it may not be abstract class, any class inheriting from another class is a relationship only, guys. Okay, that is an extra thing anyhow, but okay, so we cannot directly create an object for the abstract classes, and by using the extends keyword, we can create child classes for the abstract classes and implement the abstract methods of the parent abstract class in the normal child class. And for that normal child class, we can create the objects. Okay. Here we have to use extends keyword to inherit the abstract classes. Into the child classes to inherit the abstract methods of the abstract classes, we have to use extends keyword. We have to understand. Okay. We have to use extends keyword. Now, the other thing is can have constructors, guys. Inside the abstract classes, we can create constructors, guys. Inside the abstract classes, we can create constructors. Okay. Here, anyhow, yeah. Give me a second. So here I'll mention here, coming here in the abstract classes. Okay. In the abstract classes, we use extends keyword in order to inherit the extends keyword to be used to be user to inherit abstract extends keyword to be used to inherit abstract classes. Okay, in order to inherit the abstract classes, we have to use a normal class. Also extends keyword only will use, right? But coming to the interfaces, we have to use implements keyword for a particular class to inherit the by default abstract methods of the interfaces. Okay, we have to use implements keyword to be used to inherit interfaces, to inherit user to inherit interfaces. Okay, implements keyword need to be used to inherit interfaces, guys, whereas extends keyword to be used to inherit abstract classes. Fine. Extends keyword to be used to inherit the abstract classes, whereas implements keyword need to be used to inherit the interfaces. And the next thing is, this part is also clear. We can create constructors inside the abstract classes, guys. Constructors can be created inside the abstract class. Constructors, abstract class can contain constructors, guys. Constructors can be created otherwise. Inside the abstract classes, we can create constructors, but here constructors cannot be created. Constructors cannot be created in interface. Okay, inside the interface we cannot create the constructors, but inside the abstract classes we can create constructors. That's another difference. Can have constructors, and here I'll write down. Can't have constructors. Okay, we cannot create constructors inside the interfaces. Now coming to the variables, guys. The next thing is important thing only. Coming to the variables, guys. Variables inside the abstract classes are normal variables, guys. Okay, whenever you create variables inside the abstract classes, normal variables will be created. Okay, normal variables inside the abstract classes are normal general variables that you create in any class. But the variables that you created inside the interfaces are by default variables created inside interface are by default variables created inside the interface are by default static and final and public type. Static, final and public type, guys. Okay, generally static and final will say constants, otherwise constants, guys. Okay, variables created inside the interface are by default static, final and public type. Okay, whereas the variables created inside the abstract classes are normal variables. That's another thing. And usage wise, theoretical usage is that when we go for abstract classes in real time, okay, when you use abstract classes is that you don't want to implement everything inside the single class. Some portion of the abstract class you don't want to implement and you want to share them. Okay, the implementation will be shared across multiple related classes. As using multiple classes, you will perform the implementation where some portion of the implementation of the required thing will be implemented in the abstract classes. Whatever that is not implemented in the abstract class can be implemented by related classes, which are nothing but the child classes of the abstract classes. By making the related classes the child class of the abstract class, we can share the you see, or use it for shared code among closely related classes, close related classes, where this abstract class, whatever the implementation is done, will share, and whatever that is not implemented can be implemented by its child classes in its own versions. Okay, that's the thing. Coming to the interfaces usage, guys. Interfaces usage is completely different. And before that, is there anything here? Yeah, that's okay. Interfaces are used to define capabilities. They are not, the purpose of the interfaces is full abstraction. Okay, whereas purpose of the abstract classes is partial abstraction. The purpose of the abstract classes is partial abstraction. Okay, the purpose of the abstract classes is partial abstraction, where partially you will implement something and remaining portion will be implemented by shared classes, like related classes. Remaining things will be implemented by the related classes, guys. Remaining things will be implemented by the related classes, child classes, like that. Okay, whereas interfaces will only define, okay, will only define all the, by default, all the methods inside the interfaces are supporting the full abstraction. So by default, they are abstract methods. By default, they will not contain the implementation. And there, if a particular interface has a lot of methods and which are not implemented, what's the meaning? Interface is just defining them, and related or unrelated classes of that particular interface can implement them. Okay, they can be implemented by any class, even if they are not related or related, doesn't matter. It is not about any relation here. Okay, if their classes are not related also, they can implement the defined methods, which are abstract type methods in the interfaces. So simple words, guys. 3 points if I have to conclude, guys. Abstract classes and interfaces. Okay, if I have to conclude. Okay, so first thing is here usage also, I'll write. Okay, usage of the abstract classes is different from, okay, the usage of, okay, usage of abstract class. You have to learn, you have to know, that's the difference. And here usage of the interfaces. Usage of the interface is of full abstraction, where only defining will be there, defining of things will be there. Here usage of abstract classes is to share the code with related classes. Okay, to share the code with the related classes, and related classes can partial, whatever the partial implementation is being done, that will be shared. Child classes will implement anyhow. So these are the differences, guys. Let me copy these differences and provide in the notes once. Control C. 1 minute. Let's go here and paste it somewhere here. That's okay. Okay, so that some reference will be there. Okay, anyhow, I explained all the theoretical stuff, guys. Let's go and explore all this explanation in a practical way. Okay, how to do that in a practical way? I'll go to this Eclipse IDE and create something like some package I'll create, guys. I'll just name this package as abstraction. Okay, either partial abstraction or full abstraction, right? Abstract classes are all about partial abstraction. I told you here, abstract classes are all about partial abstraction, whereas interfaces are all about full abstraction. Okay, so anyhow, I'll create for sample, I'll create an abstract class, guys. For sample, I'll create an abstract class. Public, sorry, here I have to give a class name. Let's say I'll just give a class name like animal or something. Click on finish. So this is a normal class, guys. First of all, this is not an abstract class. Whatever the class I created here, animal class is a normal class, guys. In this animal class, if I create a method public void sample, you see I can create a public void each kind of method if I create, let's say, and this particular method can contain a method body. Like I can write system.out.println. Okay, without any problem, I can write, okay, animal is eating. Animal is eating. Okay, this particular class is a normal class, and and it's not an abstract class, it's a normal class. I can create the method. For example, if I create one more method like public abstract, I'm providing some keyword known as abstract keyword, guys. Okay, a public abstract void sleep. Okay, here I put a semicolon, guys. You see, here, if I try to give the method body here, if I try to give the method body here for this particular method, no abstract modifier or keyword is mentioned here. Here, abstract modifier, that is non-access modifier or keyword is mentioned here from Java. And immediately I'm getting an error for this leave method saying abstract methods do not specify a body. Abstract methods do not specify a body. Remove the method body, it's coming, okay? So I have to remove the method body, guys. Here, this particular method, which is the non-abstract method, concrete method has the implementation, whereas this is only definition of the method. I cannot implement it because I already got a compiler error. Still, I'm getting the error because normal classes cannot hold the abstract methods. Normal classes cannot hold the abstract methods, guys. So hover the mouse, it will say that the abstract method sleep in type animal can only be defined by an abstract class. Here also I have to provide abstract, then only the error will be gone. Now finally we have concluded with a finally to the end we got a result as abstract class. Abstract class can contain both non-abstract methods or concrete methods which can contain the implementation, or and at least one abstract method should be there. Okay, inside the abstract classes, both abstract methods and non-abstract methods can coexist, guys. Okay, that's the thing. It's all about partial implementation, guys. Partially it's implementing something and it's not implementing anything here. Okay, that's clear now. Abstract classes are all about partial abstraction, can contain both abstract and non-abstract methods. And here, the next point here is, okay, then the other thing is like, what if I create an interface, guys? What if I create an interface? To create an interface in Eclipse side, I have to say new and select the interface option. And here, I'll just name the interface as bank interface, click on finish. The interface will be created here. Inside this interface, when I create a method, public void, okay, deposit money. If I create a method like deposit money here and try to create a method body, right, immediately I'm getting an error saying abstract methods do not specify a body. You see, did I mention any abstract keyword here? But by default, the normal methods that are created in the inside the interface are by default abstract. Then it cannot contain the method body. Okay, any methods you create, guys, only definition you will use. Okay, transfer money. I'm not giving any abstract modifier keyword here, and but I'm just giving the method body. It's not taking, you see, abstract, because by default they're abstract methods, guys. By default the methods inside the interface are by default abstract methods. Public void withdraw money. You see, all the methods inside the interface are by default abstract methods and they cannot contain the method body. But the thing is that things got changed, guys, from the Java 8 version onwards. Java 8 and Java 9 version, some methods got introduced like default methods, static methods, and private methods. They can contain the method body. What if I create a method like this? Okay, default keyword I have to use default void. Okay, some sample, and you can create a method body. You see, system.out.println inside sample method. You see, I can create a method containing, but the purpose is different. It's not to disturb the full abstraction here. The purpose is completely different, guys. Different why we have to create the default methods. Okay, the purpose is different. It's not to break the full abstraction. Interfaces are actually meant for full abstraction, and but over a period of time when the project size becomes very big, and suddenly if you introduce kind of abstract methods inside the interface, right, all the other child classes will get affected. To avoid that, they came with some kind of methods like default methods, static methods, etc. Guys, here if I use static void sample2 also, you can create, they can contain method body, guys. If that particular thing contains a static keyword also, no error will come. Inside sample2 method, okay, sample2 method, they can contain the method body, guys. Apart from that, in the Java 9 version, private void sample3, I'll say this private method also can contain the method body inside sample3 method. Other normal methods are abstract methods, guys, to support the full abstraction concept of the interface. They got created, okay. But when you specify the default static and private modifiers, right, the methods inside the even interface also can contain the method body, okay. The full abstraction is there. Still, Java 8, Java 9 onwards, we got some extra methods, where you can contain some methods containing the method implementation in the form of default methods, static methods, and private methods. Okay, fine. But purely interfaces are actual purposes for full abstraction. Abstract classes actual purpose is partial abstraction, where they contain abstract and concrete methods and non-abstract methods. Some containing the doesn't contain implementation, some can contain the implementation. Okay, and here I told you, right, cannot create the objects, and I'll tell you that. Okay, I'll go with that. Don't worry. So here full abstraction and methods, okay? Methods created inside the interface are by default abstract, and here partial abstraction, and here full abstraction, zero implement. Partial abstraction means partial implementation. Full abstraction means zero implementation. Okay. So here we cannot create objects. Here also we cannot create objects. Whether you are trying to create objects for the abstract classes or whether you are trying to create objects for the interfaces, it is not possible. I'll try to show you that. I'll try to create a demo class, guys. I'll just to create another class like demo class with a main method, and in the main method I'm going to create an object for this abstract classes, and you can clearly see that you cannot create objects, guys. You will get a compiler error saying that cannot instantiate this bank and animal. Animal is the abstract class, guys. First I'll show you whether we can create an object for the animal class. Animal is equal to new animal. Animal is equal to new animal. Like this I'll create, and here you see cannot instantiate the type animal. This is not possible. The other thing is for interface also it is not possible, guys. Bank is equal to new bank. For interface also we cannot create objects, guys. Similarly, for abstract classes we cannot, for normal classes we can create objects, but for abstract classes and interfaces we cannot instantiate or we cannot create. You see, cannot instantiate the type, bank will come. But what if I still want to access the variables and methods of this particular interface and abstract classes and interface? In that case, we have to create the child classes for this. In that case, we have to create the child classes for this abstract class. Okay, so I can create a child class here. For example, class dog, like that, some child class extends. What keyword I have to use, guys, to inherit the abstract classes? I have to use extends keyword, guys. Extends keyword need to be used to inherit the the abstract classes. And here error will come because there are some methods in the parent abstract class which are not implemented. Until they are implemented in the child class, add an implemented methods. This particular method, if it is implemented in the child class, right? Okay, by giving some body like system dog is sleeping. Okay, once the moment you implement this, right, sleeping, then errors will be gone. Okay, here remove the abstract keyword, guys. Remove the abstract keyword because you are overriding this. You are overriding the abstract method. Okay, here you are override. Okay, here you are overriding the abstract method which is not implemented in the parent class. The implementation you are providing for the child class. So in this case, what you can do here is, even though you cannot say animal is called new animal, you can create an object for the dog class and assign that to the variable of the animal class if you want. Okay, earlier you are not able to animal is equal to, or dog d is equal to, okay, dog d is equal to dog is equal to new dog you can create, or animal is equal to new dog, but object should be created for the child class which is implementing all the abstract methods of the parent class. Okay, this is fine. And coming to the interface, also same thing, guys. Interface also same thing. For interface, directly you cannot create an object, but we have to create a child class which can give some class name like HDFC Bank. HDFC Bank implements HDFC Bank implements bank, let's say. Okay, for the mouse and add unimplemented methods will come. Once you override all the methods of all the unimplemented methods of the bank interface in the child class of the bank interface, right? Okay, here you can write the sample statements like system.out.println, and deposit money is implemented. Deposit money, which is by default abstract method in the interface, in the parent interface, is here we have to use implements keyword, guys. That's what I'm telling you. Here you cannot create the objects directly. You cannot create the objects directly, but for abstract classes we can create a child class and then use extends keyword to inherit. Okay, similarly for interface also we cannot create the objects directly using the extends keyword. Okay, we can make a child class, implement the parent interfaces, and that particular parent interface, okay, that particular parent interface abstract methods will be inherited by will be overridden by the child classes, and for that child class we can create the objects. Okay, here also the same thing. I'm just implementing the abstract methods of the parent interface in the child class. Here we have to use implements keyword instead of extends keyword. That is another difference. And here I'll write money deposited in HDFC Bank. Money transferred to HDFC Bank. Here money withdrawn here I'll write down some.out.println money withdrawn from HDFC Bank. Like this, I can write the code, guys. Like this, I can write the code. I can implement the methods. Now, once I implement the methods, right, I can create an object for the new HDFC Bank. You see, I cannot create an object for the bank interface, but I can create an object for the child class of the bank parent interface and assign that to the bank interface object. And that is okay. Or you can also assign it to the, you can also do something like this, like HDFC Bank, HDFC Bank, H Bank is equal to HDFC Bank also you can write. These are the ways, guys. Directly, you cannot create an object for the abstract classes or abstract interfaces, but you can create the child classes which are implementing the abstract methods of these interfaces and abstract classes. And for that child classes which are implementing all the abstract methods of the parent interface or parent abstract class, you can create the object, guys. And okay. So the next difference between the abstract classes and interfaces is that abstract classes, we can create the constructors, guys. Let's go to the abstract class and try to create a constructor, guys. You know about the rules and regulations of the constructor, right? Public return type won't be there, and the name of the constructor should match with the name of the class. It looks similar to the method. You see, system.out.println inside constructor. Okay. But what about the interface? Can we create constructors in an interface? Okay, we cannot create constructors in an interface, guys. Let's try to create. You see, interfaces cannot have constructors. Interfaces cannot contain constructors. As I mentioned, can't have constructors. We'll get a compiler error saying that you cannot have the constructors here. Okay, interfaces cannot have the constructors. Okay, done. Next one is variables that are created inside the abstract classes are normal variables, guys. Okay, there's no particular specialty about the variables. If you create some variables inside the abstract classes, int a is equal to 5, you see, it is a normal variable. It's a normal variable. Okay, it's a normal variable, guys. But the variable that you are creating inside an interface, it's a normal variable. Whatever the variable you create here is a normal variable. Okay, before which you can mention public, you can mention private. Okay, then you can mention default, then you can mention protected, anything you can mention, guys. These are normal variables. Variables that are created inside the abstract classes are normal variables. These are normal variables that the way you created variables in the classes and use, right, the same variables. But if you create the variables inside a interface, for example, string account type 1, put a semicolon here, immediately error is coming. It's not a normal variable, guys. Here, if I don't initialize also, nothing will happen. You see, it's a normal variable. No errors are coming. But here, if I don't initialize, I'm getting an error saying that the blank final feed, it's saying that it's a final by default. It's a final and static by default, guys. You have to final they are like constants, guys. These are like variables inside the interface are not actually variables. They are like constants by default. They're static, final, public by default. Okay. So here, string account type, I'll just give saving. So I have to initialize the final variables, you know, right? You have to initialize them, and you cannot update the value of this variable somewhere here. If you say account type is equal to current, you cannot do that. You cannot update the value of these variables, guys, anywhere. This is not possible because they are final type. So interfaces inside the static and final type, and in public type also, and public type, static, final, and public type. Okay. Whether public modifier is mentioned here or not, they're public type only. As you can clearly see, implicitly they are public, static, and final type based variables. Whereas in the abstract classes, the variables are normal variables, similar to the normal classes in Java. Okay, but interfaces, the variables are by default final, static, and public type. Implicitly, they are by default there. Okay, the methods inside the interface, normal methods inside the interface are by default abstract type. The normal variables inside the interface are by default public, static, and final type, guys. Okay, the usage I already explained, guys. Okay, the usage I don't have to practically demonstrate. Okay, so this is how, guys, these are the different differences between the abstract classes and interfaces in Java, guys. So with practical demonstration and theoretical explanation also, I have answered this question for you. So that's all for this session. Thank you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, what is the keyword used for inheriting the interfaces in Java? Let me answer this question first theoretically, followed by practical demonstration. Okay, so what is the keyword that can be used for inheriting an interface in Java. In Java, if you want to inherit an interface, a class can inherit an interface, or another interface can inherit this particular interface. Based on which item is going to inherit this particular interface, we have to use such kind of keyword. For example, if a class is trying to inherit an interface in Java, then the class have to use a keyword known as implements keyword. Okay, if a class want to become a child class of an interface by inheriting an interface in Java, implements keyword is being used by a class to become a child class of the interface. Whereas if a particular interface in Java want to become a child interface of this interface, or to want to inherit this particular interface, then that interface that which want to become the child will use extends keyword. Okay, interface inheriting interface will use extends keyword, whereas class inheriting an interface, that particular class will use implements keyword. Let me practically demonstrate so that we'll understand the answer for this particular question in a better way. Further, I'll switch to this Eclipse IDE, guys, and here I'm going to create, already inheritance is there here. Let me go it here and just create one package here. I'll just name this as one and move all these files into this one package. Okay, the previous demos, so that it will be clean. And now here I'm going to, what happened here? Okay, now I'll create one more package. I'll just name this package as .2 sub package I'm creating anyhow. Under the two package, I'm going to create a interface, guys. First of all, I'm going to create an interface. I'll say interface P. This interface I would like to make parent for the classes and interface, other classes and interfaces, to show you which keyword will the child class will use to become a child class of this parent interface and all those stuff. Now this is an interface, guys. Okay, you can write some variables etc. into this. Okay, string account type okay is equal to savings. Like this, I'll create one variable, guys, just for sample instead of keeping it empty. Now if I want to create a class, guys, okay, if I want to create a class, let's say class C, I'll say, and if I want to make this particular class a child class of this particular interface, then I have to use which keyword, guys? We have to use implements keyword. Okay, implements keyword. Class inheriting an interface, we have to use implements keyword, interface P. You see, class C is able to implement interface P, and system.out.println. Okay, you can create a method otherwise, public void sample, and since this particular class, the class C has become the child class of the interface P because of this implements keyword, we can directly use this system.out.println. Here you can print it out, account type, then print it out without any problem. Similarly, if you want to make a particular interface, implement this interface. Okay, the particular interface using the interface keyword, I'll create an interface, guys. Interface C, I'll say. The name of the interface is interface C. And if I want to make this particular interface C a child interface of this parent interface, here for an interface to become a child of another interface, we have to use extends keyword, guys, not implements. Extends keyword. Interface inheriting another interface, we have to use extends keyword. A class inheriting an interface, we have to use implements keyword. Remember that. Okay, here also once inheriting is done, here also I'll say sample2 or something, and just create a method and system.out.println. Here also I can print the account type. Okay, done. This is the account type, right? This is the one. Any mistakes? Okay. Okay, you see the problem with this, you cannot create a method inside an interface, guys. You see, all the methods inside the interface are by default abstract type. So here you have to use a keyword like default or something, then you can use it. Okay, there are some special methods in interface like default, static, and private, where we can implement the interfaces, where you can implement the methods. Otherwise, by default, normal methods inside the interface are abstract. So either you have to provide default, private, or static keywords here. Okay. Yeah, fine. Anyhow, as you can clearly see, the topic here is very simple. If a class want to become a child class of an interface, it has to use implements keyword. If an interface want to become a child class of another interface, it has to use extends keyword. Remember that, okay? So what is the keyword used for inheriting the interface in Java? You have to give these two answers, guys. First, start with implements. A class inheriting an interface have to use implements keyword to become the child class. A interface implementing or inheriting an interface have to use extends keyword to become the child interface of the given interface. Okay, so with practical demonstration, guys, you can take a screenshot of this code and practice in your local machine. So hope guys have taken the screenshot of this code. So with practical demonstration and theoretical explanation, I've answered this question for you. So that's all for this session. Thank you. Bye-bye.